All right, looks like we've got a few folks coming in there this morning. Welcome everybody to the part one of a two-part series, Moving Beyond Net Zero. Let everybody hop on there. On this fine Thursday afternoon building science webinar, we've got some really interesting and knowledgeable and helpful speakers, experts joining us today. Do a little introduction as we get started here. You'll notice that if you are having some technical difficulties, we've had a few folks that have experienced a few technical issues with Zoom. Apparently there was an update. If you're having issues, just put it in the chat, and Stacy Cooper, who operates as Building Knowledge Canada webinar, is the host, and she'll try to help you out if you're having issues with your audio or video today. Nice to see a number of you on here today. Bear with me today. It's definitely it's a remote for me this afternoon. I'm sitting in the fine province of Saskatchewan, near downtown Saskatoon, and it's, what is it, minus 14, minus 15. The sun is out, and a little snow. So. All right, folks, maybe we'll go ahead and get started. So welcome again to the Advanced Building Science webinar series. This is a two-part series specifically for the home building industry, and talking about this going beyond the energy and now to get into the carbon. And what does that mean? So we're going to be going down some rabbit holes today and tomorrow. And these sessions are not meant to be concise or overall. They're just meant to spur some understanding and to maybe spur some question asking as well by the industry. Our panelists that we have with us today, Mr. Sean Mason, Sean.ca Homes out of the Barrie area. Sean, many of you would know Sean. Sean's been a phenomenal example to our industry. Not only has a great mind on the building science, even though he wouldn't admit it, has done some really fantastic things. Sean was actually involved in the early days of the development of the Energy Star program back in the day, like what was that, 2007, 2008. We also have Peter Moonen. Peter's been with the Canadian Wood Council. He's their National Sustainability Manager. And Peter is, I have heard Peter's name for years, and it was very interesting. I was talking to Robert Jonkman, who participates a lot with the Canadian Homebuilders, and I said, Robert, you've got experts. He said, oh yeah, we've got Peter. So it's really good to have Peter on today, and he's going to share a very important perspective when it comes to carbon from the Canadian Wood Council and some of the work that they're doing. And Derek Hickson. So Derek's having a little bit of technical issues today. Derek is helping with the launch of a new company called Enbridge Sustain. If it happens today that Derek can't get on, we'll roll him into the next session. So don't worry about that. We've got plenty of content to go around for the day. So myself, Andy Oding, Building Knowledge Canada. Again, we're really privileged to have guest speakers like we do have here on today. Our company participates in a number of codes, develops codes of standards, but more importantly, we get to work with a lot of really cool clients out there. So a little bit of housekeeping rules, just to keep in mind. If you have questions about the content today, questions about the content on carbon, or questions for the panelists or thoughts, please put those in the Q&A button. In the chat, please in the chat, put in only the items that relate to technical issues. So if you're having technical difficulties and so on, you can go to that part. Be considerate as well in the chat. I know that this discussion about energy and carbon, it's a tough one. We are definitely in a phase where we have to ask some very hard questions, but this is good. It's like anything else, right? This discussion that causes lots of questions, it might spark some productive arguments. But it's like exercising a muscle. Nothing happens until you start to put strain to it and exercise it and develop its elasticity. So that's a good thing. There is a survey as well that's going to be sent out afterwards. So please send your feedback. All of the presentation materials today, PDFs of the presenters' materials, as well as copies and the video recording, will be sent out to everybody after the session today. And then after that, These are actually held on our website with a number of other building science videos and short webinars under resources under the Building Knowledge website. Keep in mind too, there is closed captioning. So Stacy has been great. Stacy and on our team and Emma have made sure that we do start to include closed captioning. So it's enabled. So if you require transcripts while the hosts are speaking, please go in, and it sits in between the controls between record and reactions at the bottom of your screen. The agenda for today is going to look a little like this. I'm going to spend 10, 15 minutes maybe talking about some contextual items. Again, what are we seeing in the industry, the home building industry in particular? What can we sort of expect with programs and codes as they evolve? And again, these are just the opinions of Andy and Building Knowledge Canada. It's not the opinions of anybody else. And then Peter is going to share with us some thoughts from the Canadian Wood Council around this embodied carbon thing. And, you know, wood is good, right? And we'll learn more from him. Derek, if he's able to join us, is going to talk about the Enbridge Sustain solutions. He might join us next week if he can't join us today. And then Sean's going to follow up with a builder's perspective. Sean's doing some phenomenal work. And the good news is Sean's willing to share the good, the bad, and the ugly, right? It's the practical application of all this interesting stuff that we think about, but then someone actually has to go and do it. And that's the builder. He'll give us a perspective, and then we'll have some time for question and answer. Real quick, before we get started, as you know, we always like to know, where are you coming in from today? And what keeps you busy day to day? So Stacy, if you want to roll the poll, please folks, take a minute and tell us where it is you're from. Notice from a number of you that, yeah, it's quite a broad representation across Canada here. So we got some folks in British Columbia and Alberta. Looks like we've just got every province except Quebec, maybe. Pretty cool. Good. It's good to have a number of you on today. Atlantic province has got some folks from the US, and we've got some other. So if you're other, please feel free to put in the chat. That's interesting to know where you're from. If it's not the US or Canada, where you're from, just throw that in the chat. Good, thanks, Stacy. Let's find out what these folks do. So again, take a minute, folks. Tell us what you are, what's your background, what do you do day to day? So we've got some architects, we've got some engineers, we've got some energy advisors, registered energy advisors, consultants, mechanical folks, renovators, developers, architects, building officials, and again, others. So yeah, if you're not listed in here, feel free to put it in the chat. It is interesting to get acquainted. It's also fascinating, I think, to all of us to understand that this is not about one industry. It's multiple industries that are needed to help move things along, and a lot of collaboration as well. Awesome, thank you. So Stacy, go ahead and roll those results if you want. So there we go. All right, folks, thank you so much for that. Looks like we've also got some mechanical engineers from BC Revelstoke. We've got Gardeniers calling in from Winter in Belize. Very interesting. Good deal. And we've got some folks from Natural Resources Canada, policy analyst, architect, technologist, designers, housing manager, home warranty. Very cool. Very nice to have you. All right, well, let's get going. So we have the poll. So let's start out a little bit with some context setting. I do want to just remind everybody, it's a slide that we're all familiar with. We've seen a lot, but I do want you to just be reminded that with this tiered energy code that has been launched in 2020 and that all the provinces are working towards harmonization, that it was very specifically given to the standing committee the direction that this tiered energy code was not to be about carbon, it was to be about energy, and it was not to be about electrification, it was to be energy source neutral. So let's be really clear, because sometimes we, in order to understand the development of a code, we have to understand the principal directions behind it. So this was for the 2020. Now, the question is, of course, with this tiered code, and of course, Ontario is sitting at about tier 3. We've heard, you know, Alberta might be tier 1 or tier 2. It depends on where the provinces want to land, but somewhere on these tiers. The real question is what impact does this energy code have on embodied carbon and on carbon in general? So that's sort of a question we need to ask ourselves. One of the things that I think we do sort of know, and again, this is just our opinion from information we've gathered notionally is, the national building codes of 2020 and into 2025 will continue to deal with energy reduction only. When we get into 2025, you're going to see the release of alterations to existing homes and buildings around energy, but you might also see, who knows, you might also see a little bit of operational carbon. In the future, some of the future development code cycles, there is already some discussion and there's some work being done, I believe, on policy side around resiliency. And really, the point we want to make with this slide is this really is lockstep with what we're seeing south of the border. We're starting, and not just starting, but what we've seen for a number of years in other countries as well, too. It's interesting, if you do look south of the border, there underway is the 2024 IECC, and that is the residential code for houses and small buildings. And what's fascinating about it is buried in that energy code, they do start to talk about things about lowering carbon. There is discussion in that code about using things like even renewables to offset certain percentage of energy. So they're starting to move beyond that. And I think we'll start to see some similar trends here. Of course, I'm going to show you a couple slides that have been a little bit informative. To some, they have been startling, but has caused us to rethink our focus on energy and carbon. And of course, a lot of the work has been done by Chris Magwood and a number of others. This is an older slide, 2018 or so, from Architecture 2030, that pointed out very early that, listen, the concern isn't just energy, it's also carbon. That's really the big one when it comes to climate change. And what they noted was that the operational carbon, we can sort of understand, that's the carbon that's emitted from the operation of the building and the home, but the carbon that's actually from the manufacturing side and the installation, wow, that's almost half the carbon output. So this is sort of important to understand. So just so you know, to be really clear today, when we do use terms like embodied carbon or operational carbon, this is where they sit in the full life cycle assessment. So we're not talking about all of the points of life cycle assessment for carbon emissions. We're talking about really sort of two or three of the most important. So embodied carbon or upfront embodied carbon, cradle to gate, is that raw material to manufacturing, something that you could get on an EPD that could be easily used in reference. And then of course, operational carbon that comes from the home. One of the points, again, that's made by Chris Magwood, Builders Through Climate Change, and even Natural Resources Canada, is that as we reduce the energy use in the home in the tiered code and we reduce operating carbon, the embodied carbon becomes more and more important. And that's going to be as soon as 5 to 10 years out. It's going to become the biggest part of the pie for us to solve. So we need to start to develop tools. This is another one. This is a report that was done through the Endeavour Centre with Natural Resources Canada that took a look at the tiered code and said, wow, hold on a minute. If we're not careful with the tiered code in that we start to use materials that have high embodied carbon, we could see higher tier homes actually have the unintended consequence of emitting more carbon. So you can imagine adding lots of more insulations or lots of more complicated technologies that have high embodied carbon in the manufacturing process could actually end up putting more carbon into the atmosphere than what we're saving or the life of the home through operational carbon. Now, this was not a blanket statement. This was simply an observation. And it wasn't that if we keep doing things, today, or this was based on some pretty dramatic assumptions, but it is good to keep it in our headlights. The tool, I do want to bring this out. There's a training session coming up at Interquality over the next week or two, and it's training and around the use of what's called the Material Carbon Emissions Tool. It's been developed by the LEAP team, Natural Resources Canada, the Endeavour Centre, Builders for Climate Action, CanMet. All these folks are involved in developing this tool. And I wanted to give you a snapshot of what this tool is, because you're going to learn more about it in the future. And the reason it's important, again, for our talk today is because we really are focusing in on that Part 9 low-rise residential stock in Canada. The Material Carbon Emissions Calculator tool, again, some of these tools are courtesy of the LEAP and Enercan and the team that's developing the MCE training. It is an Excel-based tool. It can be used by energy advisors and other professionals. It bolts onto the energy model and starts to give a sense of not only operational carbon, but embodied carbon. It applies, everything from environmental product data sheets from certain materials. In the lack of a material, it'll provide industry averages. So again, you can learn more about this in the course that will be at Interquality shortly. I did want to show you some of the results though that come out of this tool. We took a simple home actually that was built in Ontario, and we did an analysis. I want to show you a quick, sort of quickly what it does. So here was the home, climate zone 6. So it's up on Georgian Bay, and we found out that using the MCE tool in HOT 2000, this home had operational carbon over 30 years, about 100 tons. And the material carbon was about 55 to 60 tons of that. So the total carbon use intensity, if you will, over 30 years was a total of 157. What's interesting is with this tool, you can actually do a comparison. So on the left, this was the home as it was built. And what happened was we took and we applied a little better insulation materials. In other words, we took, a typical old traditional XPS insulation and applied the new low carbon NGX board. We applied things like air source heat pump, a little bit of air tightness. We applied a different cladding, and we were able to take it to the results on the right and actually had a overall carbon emissions reduction of 52%. So, and again, some of these could be considered fairly aggressive by some, but really these are sort of readily accessible solutions for homes today. So a big difference both on the embodied and upfront, and of course the long term as well. What were some of the big hitters on this house? Well, if you could move to a carbon smart insulation, and again, very general term, what that means is maybe you'd move from an XPS to maybe a new XPS that has a better blowing agent. And again, we're seeing that with all types of foam boards. You could consider things like, even fiber-based materials as well. You could consider, cellulose or glass, either one. But again, we'd advise go back to EPDs, have a look at them. Concrete, of course, everyone's on concrete. Like, we got to do something to concrete. And it's true. In this house anyways, if you change that concrete mixture a little bit, that you could have the second biggest impact. And then the bottom one was they actually were using a fiber cement board siding on a lot of their homes. And we found that if you actually look at a little lower carbon fiber cement board siding, something that's newer to the market coming up in the manufacturers, that they could then make a difference. On the operational carbon reduction, here was the big numbers. Here are some numbers where they can make some big carbon reduction numbers. And what you'll see here is that you've got 44, you could reduce 44 tons over 30 years. Again, remember, this isn't upfront, this is operational, by moving to, let's say, a dual fuel air source heat pump. You could reduce 17 tons by going from a typical domestic hot water heater to something that would be like an electric hot water tank. And again, we're not championing electricity because there's a lot of unintended consequences that come with this too, but this is the difference that it makes. Or a simple measure like air tightness, 11 tons, just because you made the home a little tighter. So again, it's, I think the exercise, the point we want to make here is that over the next couple of years, the exercise is going to be about benchmarking where we are today, and then what are the low-hanging fruit that we can do that we can make a reasonable improvement on. And again, just by showing these, which are some simple measures, we could hit a 50% reduction in the total carbon emissions. Just a quick selfish shout out. This is the carbon reduction strategies training that'll be held by Interquality. It's on their website. You can sign up. It's November 22nd. It's 9 to 11:30. It is online. We're going to be diving more into carbon. We'll be looking more at the MCE tool and some of the work that the LEAP team has developed that way. Peter, we'll bring Peter online here. Peter, are you, I'm going to stop sharing my screen, and you can come on and share a little bit of what you have learned over a wide number of years as the sustainability expert at the CWC.
Well, I always hate it when people call me an expert, because I've found out that the more I learn, the more I realize I don't know very much. So
Isn't
but
that
that's probably a better thing than the other way around. So sorry. I thought I would just have some of my musings around wood and carbon and construction and performance, and talk about how we as a wood sector are looking at it as both an issue but also as an opportunity. So I just wanted to pose a question. If I were to invent a material that is all of these things, it's a carbon sink, it's renewable, reusable, recyclable, organic, cleans the air, stores carbon, produces oxygen, gives us a material that is basically, it's a self-replicating solar-powered carbon dioxide sucking machine that stores energy in a building material. I'd probably be rich, but we already have that. And it comes from forests. And this is the first key spot around wood and sustainability in construction. Typically, we say, well, we want to sink carbon into the forest, we want to sequester it in buildings, and we want to substitute it for other higher intensity materials where appropriate. And I should say, all buildings of necessity are made of different materials. And if someone said, well, you need to build it with one, I'd build an igloo, but they're not terribly practical everywhere. So let's understand that all construction is by nature hybrid construction, and we have to pick and we have to know and pick the right material for the right job. When it comes to forests, it should not be 3S, it should actually be 4S, because it all starts with sustainable forestry. One of the things, going back to your high school botany and chemistry, photosynthesis. A lot of people have said, oh, how does wood absorb CO2? Wood does not absorb CO2. Trees absorb CO2 and produce wood. Wood is captured CO2. And I once had a forester say, how can something that weighs half a kilogram store 1.5 kilograms of CO2? This is how it does it, through photosynthesis. Carbon dioxide and water create sugars. Those sugars become cellulose. It emits oxygen. And wood typically is around 50%, somewhere between 49.5 and 50.5% carbon by mass.
Wow.
And that carbon comes from CO2. So that's how it stores CO2 equivalent. A lot of people we have discussions around, well, what should we do in the forest? Should we just leave it? Well, part of it's going to burn. Should we cut it down and plant fast growing trees? So Natural Resources Canada has developed a carbon budget model for the Canadian forest sector. This includes all forests, not just forest that is harvested or managed. It's all forests. And when we look at it, you can have carbon reduction or carbon mitigation, however you wish, by harvesting less and longer lived wood products and better utilization, or a mix of all three of those. And this is what they found, is that if we just focus on a single solution, we're not going to optimize what we're trying to achieve. So if you're interested in this, it's a parametric model developed by Dr. Werner Kurtz. Dr. Werner Kurtz was on the IPCC and has been for many years. He's recognized as a leader on land-based emissions, which includes agriculture, I should say. So we have to look at forest management as in a multiple ways, because how we manage this forest is going to be different than that forest. As an example, this is some research that was done out of the University of Washington. What happens in a forest, if you imagine a forest like a human population, and the trees are the people. We start off small, we grow tall pretty quickly, and then over the rest of our lives, we get big around the middle, and then we start to die off. So in a forest, it will reach a stasis. So after a certain amount of time, you'll have lots of carbon stored, but it will be in fewer but bigger trees. Where I live, I have a forest that's about 130 years of age, and it has an average annual uptake of about 35 metric tons of CO2 equivalent every year. But older forests may have more mass of carbon, but it will be in much fewer trees, and that forest will generally be in a stasis where it's not absorbing any more carbon because the dying trees are also emitting carbon. So what this model showed was that over time, this forest is going to be a stasis. But if you consider the carbon that can be stored in products, and you'll notice that the angle of the product storage is less than the angle of the forest absorption of carbon, then you can incrementally increase your carbon benefit. But the biggest bang for the buck is really when you substitute intelligently with products that are higher carbon. So Carbon dioxide, this is again a bit of chemistry, carbon dioxide has a half-life. And over time, it takes some years for the volume of carbon dioxide that is emitted to be reduced. But as for all half-life curves, and you may notice that's what this is, the biggest impact is in the first half-life. So here you have the greatest impact, the greatest radiative forcing, which is what causes climate change, global warming, is in the first 50 to 80 years. And that's why storing or avoiding emissions is so important, because the biggest impact is now. Typically, when you're dealing with wood, you're dealing with what's called a biogenic product. It comes from nature and it will go back to nature. In 2 years, 200 years, 2,000 years, it will go back to nature. But that's a cyclical event using atmospheric carbon versus fossil carbon, which was atmospheric carbon 250 million years ago and is locked up. So this half-life, what we're doing is we're delaying the emission of the CO2 by storing it in a wood product. And that radiative forcing is what we're trying to avoid. This is a quote from the IPCC in 2007, was reaffirmed in 2013 and 2019. Werner Kurtz was on that. And essentially it's saying that in the long term, if we increase the forest land base, grow more trees on that land base, and produce a sustainable yield of timber, we'll have the largest sustained mitigation benefit. That's not reduction, it's not adaptation, it's mitigation. That's pulling back from the brink, not just slowing down or changing direction. So that's where we have opportunities for wood. And when you look at what's happening around the world in the construction sector, you've got regulations, international regulations on carbon, whether it's land-based or operational or embodied. You've got energy use and performance guidelines. We have changes in technology. The construction sector is facing all sorts of opportunities and issues. I'm going to go through a few of these with an eye to how wood can contribute to what this issue has created. So we talked about the IPCC and Werner Kurtz and the carbon modeling, carbon budget modeling. This is the forest I live beside in British Columbia. And the emissions from the land base are now required to be reported to the IPCC. And that includes agricultural. It also includes all of the emissions that come from forest management and from the forest land base itself, whether it's from fire, bugs, or harvesting. So those are regulations that we have to report. Those are agreements. But if we have ways to capture carbon, and the forest will sometimes release more carbon or it will store more carbon, depending on the fire season for the most part. If we have ways of reducing or capturing that carbon, we're actually contributing to mitigation. I'm glad you had some of those photos earlier and some of the discussions from Chris Magwood, because embodied carbon is important. This is a life cycle analysis that was done for a building in Australia. And as you'll notice, the embodied carbon is 35% over the life of the building. 23% is heating and air conditioning, which is the part that's regulated by our codes. So we put all of this effort into operational performance, but we're really only addressing about a quarter of the operational energy, because no one tells anybody how much hot water to use or how much refrigeration to use. So in this LCA, the embodied emissions of a regular building were 50% higher than the embodied emissions that would be of the carbon emissions associated with that which is regulated.
Wow. So
Andrew, you mentioned that we're getting into carbon regulation. This may change. But we have to look. This is as it is now. So I talked about this forest product substitution, but didn't delete the slide. So energy use and high performance. I don't think anyone's thinking that we're not going to have rigorous energy codes. They're not going to get simpler. These are opportunities for wood, partly because of wood's thermal capability, but also because of some of the technology that is being able to be used. This is a building in Lower Lonsdale. It's a light frame prefabricated passive house panels and mass timber prefabricated passive house panels on a glulam and skeleton. And it's not an iconic building in that it's not glorious or grand, but it is eminently repeatable. This is a system. This is an approach, and that system will enable us to have more effective and more efficient buildings. It's also a zero clearance structure right up against the building behind it, and it has a restaurant.
Peter, it's interesting. This is a Nikon Contracting. That's Joe Galushan team.
I know. I know Joe well.
Yeah. And, so for a lot of the attendees, so Joe has been part of the CHVA Net Zero Council for years. Yeah. Phenomenal builder member. That's great. No, that's very cool. Thanks for that.
So, but the thing about this one that drew my attention was not that it was passive house, not that it was mass timber, not that it was heavy timber, not that it has no parking, not that it has a CLT fire separation. It's because it has all of them in a building that made economic sense.
Wow.
So we can do this, and we don't have to say, oh gosh, it's going to be 30% more expensive. That's not true. And Joe has figured it out. He's done several buildings, and it's always a treat to get on some of his sites.
Yeah.
So those technology has also changed to allow taller buildings. People in the wood industry, oh yes, let's go for 30-story buildings. You know what? I'd rather have 3 10-story wood buildings that were concrete than one 30-story building. There's a lot more buildings in that sweet spot between 8 and 14 that make business sense, performance sense, and can be done with wood. And this has come about because of technology around fire modeling, seismic modeling, the whole building information modeling, and the ability to build these buildings before. And Andrew, you talked about Joe. They built that building virtually several times beforehand to figure out the best way.
Yeah.
So, but they used I think it was CAD Maker's design. Every component was installed virtually. So another area where we have to focus is construction capacity. I don't think any builder is saying, oh yeah, I got lots of trades. No problem, I can get them anytime I want. But there's another aspect to industrialized production, and that's the accuracy, the consistency. The pictures here are from some companies that we saw in Europe last spring that fabricate modules, they fabricate panels, they build component sections or bathroom pods, that kind of thing. That industrialized production reduces the waste of materials, which always has a carbon impact, reduces the time, and consolidates where you have your skills and trades. So that's an opportunity for wood, and it's an opportunity for carbon, because this kind of construction provides a higher operational performance and a lower embodied performance because of the lack of waste. Wood product development. There was an article just earlier this week that I read. Can US-made wood insulation go mainstream? It's a product that's been around in Europe for about 30 years. We don't make it in Canada yet. And it's one of the things that, and Chris and I have talked about this, it has a very low embodied impact, and it has very, very good performance. It's about the same as XPS. But it's renewable, it's recyclable, it's reusable, unlike a lot of insulation, because it's screwed in place, not glued. And it's made with a residual material. And it's a little bit about that. There's a sawmill in Europe that burnt down in '74. The widow restored it. She makes lumber. She makes solid wood products. They make laminated decking and posts. They make glulam, cross-laminated timber, building components, pellets, energy, steam, refined fiber, and wood fiber insulation, all from this small, it's a 20-acre site that used to be the family farm in a small town in Germany.
Wow.
We can do that here. We have to reconsider how we do things, but this is the kind of operational efficiency. At the end of the day, nothing gets wasted that goes into that mill. It goes in as logs, comes out as ash or something, or a product. And I think they probably sell the ash. Mm-hmm. So this is optimizing the carbon that comes from our forests. And a lot of these are going into long-lived, other than the pellets, long-lived wood products. The other thing, I don't think there's a city in the country or in the world that isn't facing densification issues. And in Canada, I know at least in British Columbia and across our country, you can't just densify, you've also got to have performance. While at the same time, we're faced with who the heck can afford to live in these cities?
Mhm.
So how are we going to do that? It's going to go back to things like addressing the productivity of our construction sector, using cost-effective materials that enable the performance of the building to improve and reduce the impact. And that's where wood can play a role. The other things, some of the things which some of you as builders may have come across is
Mhm.
the biophilic aspect of buildings and the health of the buildings on the occupants. If you don't know Ty Farrow, please go to his website. It's called causehealth.org. I'll put it in the chat later. And he has just finished a master's of neuroscience in architecture. He's looking at the impact of the buildings on us.
Wow.
And he's examining things like acoustics, temperature, moisture, the whole, and what we see, whether it's conscious or subconscious.
Mhm.
So wood, other natural materials like stone, water, plants, sunlight, those have a positive effect by reducing our stress levels. And whether we're aware of it or not, we have stress wherever we are. There's good stress and there's bad stress. And if you think of a building, whether it's healthy or not, as sort of like driving a car uphill, but the car has no brakes. You're either going forward or you're going backward because there's no stasis. Buildings impact us, and we have to make them so that they impact us for the better.
Mhm.
Wood has been shown to reduce the stress level in both the sympathetic and parasympathetic nervous system.
That could be a whole topic on its own, Peter?
Yeah,
Any sort of
it can.
on that.
Yeah, it's a lot. We did a workshop on healthy buildings last spring. So some of the things that are driving us as a sector, the increase in whole building life cycle analysis, that is leading to federal, provincial, municipal, and designer, developer, builders requirements say we're not going to buy stuff if the upfront carbon footprint is so high it can't be justified. No sense having a super high performing building if you're offsetting that with 2 feet of polyurethane insulation just to meet some standard. So we're also, the wood industry was the first to produce EPDs. Those are being revised on a 5-year basis. Andrew, you talked about resilience, and everybody has sustainability goals. So these are some of the things that are driving our sector. And above all, materials matter and carbon matters. And as I said, there's procurement policies which are coming into place. For those of you who may not have done whole building life cycle analysis, I'd urge you to find someone who's familiar with that, whether that's in your design team, whether it's on staff, but pay attention to that because it not only helps you reduce environmental impact, it makes you more efficient. Right. The EPDs were started to reduce the impact, and that makes people more efficient. Mm-hmm. And don't be afraid to collaborate. I know CHBA has lots of collaboration opportunities by some of the sessions they have, but we need to be cohesive on our objectives and have some common tools.
That's right.
So one of the tools that we're working on is a project of the National Research Council called Low Carbon Assets for Life Cycle Assessment. We call it the LCA squared. And it's part of the government greening their procurement strategy. And we are involved in gathering information from all of the producers of various wood products. So we're focusing on plywood, OSB, lumber, I-joists, and plate trusses. You had a version of this drawing, Andrew. There's certain areas where a manufacturer has a role to play. So in this case, the Forest Products Association of Canada, which has that's a member-driven organization, they're responsible for the forest aspects, the transport to factory, and for the manufacture of the primary products. The Canadian Wood Council and the Woodworks program gets involved in assisting designers and contractors to understand the appropriate use of wood. So we play in this area. But at the end of the day, after the building has been torn down or removed in some way, what happens in this area? Landfill, the product stewardship. So it's an area that we are going to be doing some research on it, not so much to to reuse those products, because landfill occurs after all reuse, but say, what is the impact of burning or landfilling an I-joist that has 3 resins? So we're going to be gathering information like that over time. But there is a really important role in designing buildings that can that don't have to be landfilled, that can be reused. And when I say reused, it's not just, no one's going to take CLT and turn it back into a 2x6. How do we recapture the function? That's the circular economy. So when I get back to this slide here, and I say, if I was to invent this material, I'd be rich. But the question that we have to ask, and in the context of that, there is no perfect material. But if we're going to build, why should we use wood? So you think about all these attributes, all of which are important, and many of which we strive for in our designs. So perhaps the question shouldn't be, why should I build with wood? But if I'm not going to build with wood, what am I going to use that performs the same structural and comfort and aesthetic function and has as low a carbon footprint, where applicable, as wood? So with that, I'll leave open to questions. I think I'm a minute over, but I apologize for that.
No, that was very, very good. And I'm actually, I feel like I need to go back and look at your slides too. That was really, really helpful.
I'll send a PDF out to people, you can distribute that.
Excellent. No, that's good. Well, we'll keep moving. Nope, your timing was good. If you do have questions, any of you, Christopher and some of you over in the chat, please put your questions over in the Q&A. That way we can record them for folks in the future. Mr. Hickson, how are you, Derek?
I'm doing well, thank you. I was on when you said I was having technical difficulties, so I did manage to get on. Thank you, Andy.
Very good. Doing well.
The only thing we haven't checked yet is whether the slides are being run on your end or mine.
I can do either one. Do you want me to run them from this end and you can just tell me to change, or what's good for you?
Yeah, sure. Let's do that if you have them loaded up there.
All right.
Okay. Well, thanks, Andy. Thanks,
Hey,
Peter.
you're very welcome.
That was a great overview there, Peter, on the embodied carbon side. It's something that's obviously getting a lot more attention now, as it should be.
Yeah.
I hope we can address both pieces as we go forward. So for those out there who don't know me, and that's probably numerous of you, I'm Derek Hickson. I work with Embridge on a new team we've formed here called Embridge Sustain. It's an affiliate company of Embridge Gas Inc. And I've been with Embridge for just under 5 years now, but prior to that, I was in a previous life, 10 years with a large builder in Ontario, building progressively greener and greener homes, yes, culminating in five net zero energy homes we put to market just before I left. So today I'm going to talk about Embridge Sustain, which is a new function, as I mentioned. But before I get into that, I'm going to just give a quick overview of Embridge, if you want to move on to the next slide there. So Embridge Inc., as many people will be familiar with them, we do quite a lot. We have our liquids, our midstream, and we also have the large component in Ontario here is our gas distribution. We are tackling energy transition in a very serious way. We've made numerous commitments on our own emissions to meeting net zero within our scope 1 and 2, and then also reducing in the shorter term too. We have numerous strategies that we're putting in place. We just released a report, Pathways to Net Zero, which looks at 2 different pathways that could be taken to move to a lower carbon future, one that employs gas and one that is predominantly electrification. I invite everyone to read through that report, but in a nutshell, we do feel like gas will play a part in the energy transition. The high level findings there are that we can achieve comparable outcomes at a lower cost in the short term. So in terms of Ontario, we have, again, numerous pathways that we're pursuing on the scope 3 emissions front. So we have using less gas conservation focus. We have using non-gas, sort of geothermal, carbon capture, solar PV, those kind of technologies. And then we have carbon neutral gases. So we have divisions that are looking at hydrogen, also renewable natural gas. So we're we're tackling this in a comprehensive way. I'm specifically going to focus on the Ontario transition as it pertains to our new retail offering. Andy, if you want to go to the next slide, please. So coming from the builder world, I can attest to these challenges faced by customers and builders. Obviously, as Andy's slide earlier alluded to, the codes are getting more and more stringent. Municipalities are taking on a more active role in specifying what targets we should be hitting, and customers are demanding more from their homes as well. The challenges in just immediately going to a net zero future is, we have a high cost to adopt some of these technologies. Like, it's certainly more expensive than conventional from a capital cost perspective. And we'll talk about the operating costs in a second. Builders and homeowners, don't necessarily have the time to research the best choices, nor do they have the technical expertise. And then, the last big piece is the technologies that are coming out are becoming a bit more sophisticated than a layperson may be comfortable with and putting in their home. So, I'll talk more specifically about the technologies we're looking at, but obvious items are things like geothermal, where the operations of them are paramount. Hybrid heating, where to really capture the benefits from them, you need some smart controls, and solar PV and those kind of things, where people's comfort with having them integrated in their house might not be there yet. And if you want to go to the next slide. So that's where Enbridge Sustain is coming in. So we've launched an affiliate business within Enbridge Gas to finance, own, maintain low carbon technologies that specifically focus on bridging that gap. So when builders or homeowners are facing an issue of capital cost constraints or operating challenges, that is where we will step in to finance, design, build, and own these systems. So how does it work? And if you want to go to the next slide. So I'm going to focus a little bit more on the builders here, although we are launching this in parallel with the retrofit market and our consumer base as well. But on the builder side, effectively what happens is, when you have a project, we will meet to understand the project goals to come up with what the solutions could be. So I think it's fair to say not all projects have the same goals. We certainly see a lot of projects that are trying to hit sustainability goals and keep it cost neutral for the customer. Some have maybe a bit greener of a customer base, and they're looking for a net zero or a deep green install. So we would meet to do that. Enbridge on our side, we would design the systems, present them to you, of course, and install them. All the design fees, the installation fees would be borne by us. We would turn that into a low monthly fee for the customer, and again, ensuring that the goals for the customer are met. And then, because we would own and maintain the equipment, we would also provide ongoing support and maintenance for the customers. And we were actively, I'll talk about this a little bit later, but we're actively developing an interface for the customers to see their energy insights, to see their savings, to see how their systems are operating, and so forth. And if you want to go to the next slide. So as I mentioned earlier, we're not fully in a box yet. We will entertain this structure for any low carbon technology that, like I said, it falls in that sweet spot of like higher capital cost with more sophisticated maintenance requirements. But the three we've started with that are turnkey at this point are geothermal, hybrid heating, and solar power. And I'll talk a little bit about each of these in the next few slides. I won't spend too much time here because I don't have a ton of time, but and if you want to just go to geothermal. So for anyone who's not familiar with geothermal, this is literally meaning heat from the earth, where we would install a borehole that connects to a ground source heat pump that would provide heat for your house and potentially hot water. Of course, it's long-term savings, very close to zero carbon emissions compared with a traditional gas system, reliable, resilient, and up to 400% efficient. This one in particular, in terms of illustrating the energy as a service model that we're trying to go for, this is the one that has the closest comparison to the gas model that we currently operate under. So, as Enbridge Gas, we bury assets in the ground and we finance them over a long term. This would be the same situation. So we would put in the infrastructure and finance it over a 40-year term to get the cost of that spread out long enough so that the savings are paying for themselves. And you can skip 2 forward. I won't, because I don't want to spend too much time on the technologies in particular. So hybrid heating or dual fuel, it's exactly what it sounds like. Air source heat pumps have certainly come a long way, but we see in a lot of situations that their efficiencies drop off in colder weather. So by employing a dual system, you can take advantage of the high efficiency settings of a hybrid heating system when the weather's a bit warmer out, but then use gas for peaking or for hot water to make it. It ends up being, with smart controls, the most flexible in terms of how you deploy it, especially in terms of whether you're delivering on your carbon savings or your cost savings. We're investing quite a bit into the smart controls themselves to be able to dial that in for the customers depending on their needs. And this solution is good. Obviously for the new construction market, but obviously we have a whole host of older homes in the province that 3.7 million, where the demands currently, without deep energy retrofits, something like a cold climate air source heat pump won't tackle entirely. And then solar, Andy, if you move to the next slide. Solar probably needs the least introduction, obviously. Solar panels on the roof, and in Ontario at least, we have a net metering program. So you connect your system directly to the grid. Again, we would do the design, build, and install and service and operation of that over the long term. So that's the technology side. I think we can probably skip this too, Andy, how we work with you. The benefits, I don't know if I ended with benefits. Okay, so let me talk about, tying all of these three together and any additional solution that we put on, we're investing a lot on the energy monitoring reporting. We talk about this a lot within Enbridge, but at the end of the day, we're in the customer business. We have 3.7 million customers in Ontario. That's the heart of what we do. So when we're when we were putting this together, one of the key differentiators that we're looking for is making this a terrific customer experience. So obviously entering into longer term agreements, a certain degree of transparency is required. And we're developing a portal for both for builders and for end users, where they will be able to access their account, track their consumption, get insights into how their home is performing this year versus last year, and really understand the value that we're bringing to the table in terms of a utility energy as a service model.
Very cool. Very cool.
You want to go to the next one, Andy, there? Perfect. I thought I had another slide just reiterating the benefits, so maybe I'll just do this quickly. Again, at every conference I've been to for about 15 years, the question is, well, who's going to pay for this? What's and it's because Tim and I have been at every single conference. Yeah. Well, who's going to pay for this? Should it be that what constitutes the builder's responsibility versus potentially utilities responsibility? And this is the gap we're trying to bridge here, which is to enter that utility model of longer term financing applied to a more retail space. So if you are interested, Andy, I know we had talked about this, but if you can either do it in the chat or reach out to sales.sustain@enbridge.com, and we can match you with a rep to talk through your specific project. And with that, nice. I'll say thank you and turn it back to you, Andy.
No, that's okay, Derek. That's phenomenal. So yeah, I'll have Stacy and the team maybe put that sales as Sustain Enbridge over in the chat, so you folks can do a click on there. But yeah, I just want to bring this around, Derek. We've been talking about this for 10 plus years. We have, these really good builders and developers that are ready to do these really hyper efficient communities. But it has been so frustrating because one of the biggest barriers has been, we'll just come out and say it, has been utilities. And a lot of the barriers that the utilities face is the regulation. And again, finally, there's a partner. Here you folks are saying, all right, we're in this. And of course, we understand there has to be a business case. But finally, there's someone at the regulated stage, at the community stage, that understands planning and development, all those really important things that can help the developers. Because to date, it has been a roadblock. We've been at meetings where a municipality will desire to have net zero low carbon communities, and yet the local utilities are like, we're sorry, if you're talking all electrification, here's the additional cost to upgrade all the servers in the grid. We're not ready for a hot water electrical load in the morning. But no one's willing to actually come out and say, here's some solutions, here's the partners, here's how we can do it. It just seems like it was barrier after barrier. So this is a breath of fresh air. Now we know it's not going to be perfect, right? But it's sort of cool to see this happening.
Yeah, absolutely. Like you said, it's been a long time in the coming. I saw there's one question here I can already see in the comments, just saying, when will we start working with municipalities and builders? And that's exactly what we're doing right now. So I know Sean is going to be on next to talk about his particular project, but we've already started to bring on builders and start to talk about ground source in particular. And I didn't mention it, but obviously, our utility model has a lot of connections in with the municipalities and with the regulatory bodies. So we're well connected there to overcome any challenges we might have with municipalities.
Very cool. Very nice. Well, awesome partnership. Okay, Mr. Derek, I'm going to move on to our Mr. Sean Mason. So Sean Mason, good afternoon, sir.
Hello.
So good to have you with us, Sean. I do have to share a memory. So Sean and I, what was it, 2005, 2006, we went with these characters. Who was it? John Godden and Tex McLeod and some of these building science geeks, Gord or whoever, and they took us. We were both builders at the time, and they said, let's go look at this cool project out in Alberta called Okotoks. Remember, it was a solar community and there was cool stuff. And I remember you and I talking about it as builders, like, yeah, this is great when you got $13 million from the government to do whatever you want. But it's interesting, Sean, the projects that you're about to show us, I would argue that you are now delivering projects at community scale that are as efficient as what Okotoks was achieving. That's pretty cool.
I hope so. So thank you.
Yeah, don't break your arm up patting yourself on the back like we say. But anyways, yeah.
I won't. Okay, well, nice to meet everybody. And Andy, thank you for the time today and building knowledge. I always enjoy working with such intelligent people. So I'll talk to you a little bit about my project and then some of the findings and what we've learned a little bit along the way. What you're seeing on the screen here is a project in Barrie, Ontario. It's got 35 net zero ready townhouses. You'll see the white ones at the back are modern farmhouse. They're fronting onto a park with the garages at the back. And then the ones fronting the main road are a sort of a take on a modern Georgian or a modern colonial. And they also have the garages at the back. They're all net zero ready. They are built so they can take, or they're designed so they can take solar in the future, but that's not something we're offering as a standard. This is a geothermal project. There is no gas at all to the townhouses, and this has been facilitated entirely by what Derek was just talking about, and I'll get into that a little bit more in a moment. The condo building there is a 38-unit, 5-story building. It is cross-laminated timber. It has gas for the domestic hot water, but then it also is geothermal for the heating and cooling. The reason we went with gas for the hot water is that we just got into this program with Enbridge too late. We didn't have an actual opportunity to redesign the building and take it at that. So that's what we're talking about today. Sorry, someone just walked into the room here and totally threw me off.
No problem.
Okay, so if you can pop to actually stay on that screen. Sorry, I've been totally thrown off my program here. Go back one, Andy. I apologize. Okay, so what you'll see in the middle there, and you'll see it in later slides, is that we have in the Central Parkette, there's sort of, we designed this during COVID. Things that people would want during COVID. And so there's a pickleball court there, there's an outdoor workout area, there is a meeting area. And then if you can go to the next slide, this is what it looks like today in Barrie, because the snow just started in Ontario. So the pickleball area turns into a hockey rink, and then you'll also see some permeable paving along the sides of the road there. So it's pretty neat. It's pretty innovative in some ways. This is all low impact development structures, and there we are. So if you move on a little bit, please. This is the summer view that hopefully we'll get back to in Barrie sometime soon. So you'll see that there's lots of area on these buildings for those are the colonials. You'll see there's lots of area for solar if we desire. And then you'll also see around some of those windows there's some passive solar ideas and some shading. Next one.
Okay. The outline. So they extend out over the window.
About 6 inches. Correct.
6 inches. Very cool.
Okay. Go to the next one, please. This is the condo building on the south side, which is this facade. We have those passive solar ideas around the windows, and then the decks cover about half of the windows for solar shading. Okay, so there you go.
Very cool.
This is a project, 8 units that we've completed now. These are net zero ready. They have solar on them. This is also a partnership with Enbridge. And each unit has 13 or 14 solar panels on it, not enough to take it all the way to net zero. You actually can't see them because of the pitch of the roof. That's steel siding, and then there's about 1 inch of insulation on the exterior and low solar heat gain, fiberglass windows. And you can move on, please. Okay, so I was here to talk about moving on beyond net zero carbon. And some of the things that I've learned is, over the years, and I told this to my partners, I wanted to be the dumb guy in the room. I wanted to get really smart people and work with them. And so through that, working with an Enbridge, working with a building knowledge, working with really smart engineers and architects really makes that effective. I think a reason, and I looked at some of the attendees here, there's some builders, but there's also some people who are not building. Right. Andy, you brought up, Okotoks years ago, and that was 15 years ago approximately. And what I think is a big impediment to people moving beyond this is there's so much information. Like listening to Peter's presentation earlier, there was so much there, and it's really, really interesting. And if you're a real energy wonk or a building science guy, which I was at one point, you can just, there's just too much to know. And I hear builders talk about how this building saves 30%, that one saves 32%. In the end, who really cares? If you're doing a better job and you're saving 30 or 40 or 50 or whatever it is, just simplify it and move forward. So don't worry too much. And I think this is one of the probably the biggest things I've learned over the years is don't worry too much about being perfect. Try to get net 95% better, move forward, and listen to your consultants. You can't hire them and tell them what to do. So some
like
of the
old saying, someone once said, don't let the perfect be the enemy of the good.
right. And I've said that 1,000 times to councils. And I've said it, and it's a philosophy that we've had to really internalize in our company. And I understand that you can do a little bit more than we're doing, but if you try to learn everything, unless you're a really big builder like a Minto, like a Landmart, like a Mattamy, and you have a department to do this, you're not going to get it done. So some of the things I'd like to throw at some of the smaller builders out there, what we've learned over the years is what you just saw on the screen was some really simple buildings. My point here is work on the building first. You can't place solar on a castle turret effectively. If you don't have the right architecture, you can't do this. So some architects will say you have to have the peaks and the valleys and the 12 pitches and stuff like that. If you do all of that, you're not going to get a great energy efficient building because you just can't fit the solar on later on, or you make it too complicated. So simplify. Mies van der Rohe had a great saying that I really liked from when I started this company was the building is done when there's nothing else you can take away. So I worked really hard by stripping the things out. And, if we were to jump back a couple of slides and look at those don't go it on, but if you were to look at those Georgian townhouses, they're simple. And I think they need to be really, really simple.
Right.
Another learning that we've really if you could pop back one slide, actually, Andy, if you don't mind.
Yeah.
This building is simple and all of the insulation is on the outside. We've got 4 inches on the outside of the foundation below grade, 2 inches underneath, which then means you need to learn how to cap it and, at the foundation. We've got 1 inch on the outside and then an R22 inside the stud. And the reason we've done that is, flip forward now, Andy, please. If you're cold, you put on your jacket. You don't eat it. You don't put the insulation on the inside. You put it on the outside. And that's something that I used to think it was so hard. And I remember going to Okotoks and, all these over the years thinking, oh my God, how are we going to do this? Get over it. Just do it. Once you decide that this is not that difficult, it really allows you to do a lot of other stuff and make it a lot easier on yourself. So sort of put some of those preconceived notions away and you can move forward with a fresh mind. On that building we were just looking at, you don't need to go back to it. I said there was 1 to 4 inches of exterior insulation. We used a wonderful window, low solar heat gain, so we're not baking the people inside. And what that allowed us to do then is we went to centralized heat throws. So we don't have ducts running to all of the outside of the windows. We have them on the inside of the walls up high, and it's working great, but that's a brand new thing. So if you think that I'm going to put 3 or 4 grand extra into my windows, but I can save $1,000 on my install for my HVAC because we're not running as much duct and we don't have as many boxes and things like that, it really makes it a lot easier. And this was actually the item I'll talk about in a second is a pilot that we did with Enbridge again, and it's aero barrier. I remember when I met with Aero Barrier, I said, we can do all of the air tightness. We can do this ourselves. We're really good at it. And we were getting most of
You were.
Yeah, we were getting, on our last site of 50 houses, we had probably about a third get level 3 air tightness. And then we did Aero Barrier, and I was really surprised. I would not build something again without this because it just makes it so much easier to just do Aero Barrier afterwards, and all of the mistakes or all of that effort we still want to do a good job on our air sealing, but all of that hard lifting, it just guaranteed so much a better air tightness. And on some of the buildings on that white block of towns you saw, we got down to level 4 air tightness. If I can guarantee that going forward, it allows me to get rid of my drain water heat recovery. It allows me to get rid of 1 inch of insulation on the outside. I can go to my center wall throws. People remark when they go into those houses how clean they look, and that's because there's not boxes everywhere.
Not boxes, and registers aren't on the floors under the windows.
Exactly.
You put your couch there.
Exactly. It's amazing. You can actually have your couch in the right spot and you don't need to worry about sitting on top of the register. And that's not sort of stuff you think about at the architecture stage, but when you're living in it, it really does make a big difference. So now moving forward, I mean, I think the learnings, the big thing here is simplify it. Don't look at being really energy efficient going forward as being that hard. It's really not. I've been very pleasantly surprised by just basically taking an Energy Star house, which we've been doing for years, making it airtight, or not airtight, but much considerably better. And you're basically there for net zero ready. Then we talk about the architecture, being able to put on solar. And then that gets me into my middle point here, the geothermal and the solar collaborations with Enbridge. So the 8 units we tried with solar, we did that as a standard. It was 60 or 70 bucks per month. It means the person didn't actually have to buy the unit. I was disappointed we weren't able to put on enough to actually make them net zero entirely, but that was a legal issue that I think was a mistake. Not allowing solar panels to overhang the party walls. But in the end, the program worked. The customer liked it. And I think we were too early in the genesis to really communicate wonderful marketing to them. I think it would work better going forward. But the one that I'm really happy with is the geothermal is going on right now for our rainwater program. It adds, so as Derek talked about, Enbridge is putting in the loops, and then they're also going to be doing the the heat pumps inside the houses. It adds about 50 bucks for each unit to a lease. Because we've done these through a PODL or a parcel of tied land, we can have the condominium enter into, even though they're freehold units, we can have the condo enter into the contract with Enbridge, which allows them to bring down the cost overall. And it also allows us to throw in some other things like bulk internet. So it helps offset. So we've done a really cheap bulk internet, and people will say, well, you can't do an apple to apple on a condo cost then, because you've got the geo in there, and then you offset it by a bulk internet and say, hey, you're getting all these benefits, you're paying a little bit more, but it's not so much. So it's the way we marketed that. So we're getting ready to now put the geo actually into the ground. We started scraping the dirt about a week or so ago. Each townhouse gets 2 geothermal loops, and that will do the domestic hot water and the heating and cooling. The customers, and at this point, when we started selling this one, the market was really hot and the war in Ukraine had just started. And everybody saw the natural gas cost jump. And when we said we're geothermal, this is when customers actually said, wow, you mean I don't have an Enbridge bill? And I said, well, you have an Enbridge bill. It's just a different Enbridge bill. But not having gas, that's actually when they got really excited on this one. So the solar was last summer, bit of a different issue. Energy costs weren't as high, but now we're selling the geothermal site through a higher gas gas pricing. And now it's actually had some real benefits. People are actually interested in this. Some of the things I like about this, Mary, I said earlier, you can't be the smart guy in the room if you're going to move forward. There's my second to last quote is from a guy named Scott Saddam. Scott Saddam is a guy who used to work for Pulte Homes in the US. He was their quality assurance manager, and then he's gone out and he's basically lectured builders for 15 years on how you can be better, how you can streamline, how you can value engineer. And he always complained that builders didn't do enough R&D and didn't innovate. I look at my little company and how we're doing some pretty cool stuff. If I didn't bring in and have partnerships with these big companies like in Enbridge, I couldn't do it. No, there's just too much to learn. And as I said at the very beginning of this, when I tried to think about being 32% better or 30% better, you just get, it's overwhelming with the tech changes and trying to be better. So if you can, if you can really look at programs like Enbridge has put out there, hire the smart guys in the room, which is Enbridge, hire them for the geothermal program, hire them for the solar program, let them take the lead, go along for the ride, and realize you're not going to know it all. Like, you hire a structural engineer for a reason, and every builder thinks we know how to run gas lines and do HVAC, but having the big company there and having their backstop, their guarantee, was really helpful for us to get into this. We've gone through a lot of learning in the past couple of years with Net Zero Ready, being Energy Star. We're in the CHPA MERB program, where the building you showed earlier was also in the Energy Star pilot, part 3 pilot. And I'm a big believer in that. If you don't create your own future, you're going to live somebody else's. So that's one of the reasons I've tried to stay ahead, and doing this type of moving beyond just energy into now carbon with something like an Enbridge has made a lot of sense for a company of our size. So I feel like I'm droning on here. I'm looking at my time. I've been 15.
Oh,
already.
that's good. That's very good. You know, Sean, is interesting. Back in the day, you and I and a couple other builders at that time were invited by Natural Resources Canada to sit on the technical committee that developed Energy Star for new homes.
Yep.
Remember that? You and I and Corey McBurney, and there were several others on that. We had a lot of fun. But it's interesting. There was a lot of strides made there. And I think
I'll take your word on the fun part.
Yeah, it was fun. So, but a lot of, we look at that program, and the reason it has succeeded, it's the single most successful program in the history of Canada, right? Energy Star, no question. But the reason it succeeded was it collaborated with builders.
Yep.
And you're sort of telling us the same message, is that the utilities and the partners that are going to work well are the ones are open and ready to collaborate with builders. One of the things we are facing right now, and again, this is just my opinion, we're struggling with some of the programs like Energy Star. We have these programs that it has been a bit of I'm going to call it the black box. There's engagement with stakeholders, but there's not direct engagement with builders in many cases.
Not anymore.
It causes issues with the program. That's right. Not anymore. And you've expressed interest with that. We have other builders expressing concerns that there hasn't been direct engagement with the builders that actually build the houses and make these things, and it causes stress in the system. So I just want to take one message out of this, is that, the reason things like this work is because you have collaborative minded individuals like Sean who want to listen. They have a lot of learnings that they can share with us, but they want to listen and they want to collaborate. And it's the collaboration that's going to help us move forward. It's not the detailed energy modeling or the detailed policy making. It's collaboration that's going to get us there.
Yeah, I agree with you entirely.
All right. Thank you so much for that, Sean. What I'd like to do is bring just a couple of you back on here. We're going to do a little Q&A. So Sean and Derek and Peter, if you have your cameras, we do have a couple questions for you folks. I'm going to jump into the Q&A here, and we've got some pretty good questions. I don't think we're going to get through them all, but let me just pick some of these off. So we had one of the first questions that came up was from Jacob. And again, if we can't answer these questions as our group, we will get answers back to you. So bear with us. First question was, when we talk about embodied carbon and concrete, for instance, Jacob says the alternatives such as fly ash, they're really struggling to actually get access to fly ash as concrete alternatives. And so I'll maybe take that one on real quick. Peter, anybody else is welcome to jump in. I'll just simply say, what we are finding with the concrete alternatives is, yes, as the demand rises and as industries change, or you have less, blast furnace slag that's available, it's harder to get access to. But don't panic. The good news is there are alternatives coming. I know the concrete industry is also looking at, going back to looking at lime alternatives as well. Peter, I don't know if I know you're on the wood side, right? And those concrete guys sit on the other, but I don't know if you've seen any movement there.
I don't know a single new wood building that doesn't have a concrete foundation, so I'm not concerned about concrete, but about being competitive. But they do have some interesting things with limestone that they're working on. I've had some chats with Adam Auer, who is their president now, and they're doing some really good stuff because they have to, because they want to, and because it's expected. So I would say that in a couple of years, you're going to see even some new improvements in what they're doing now. But I can't comment on the fly ash, but I can comment on one of the things which concrete is doing, which is both sort of fun from my perspective, but annoying, is they can get credit for using biomass instead of natural gas in their kilns, whereas we can't get credit because that's typically how we've fired our dry kilns and a lot of operations within our facilities. So,
right.
So they're using biomass.
I'll say something coming from I spent a little bit of time with industrial accounts, and some of my accounts were some of the big cement players, and I can tell you they're also very active in looking at things like hydrogen and renewable natural gas to green their operations. So there's a lot of movement going on there as well that hopefully that reduces the operational or the embodied carbon as well.
Nice. I am going to skip a couple of questions. So I want to pick ones that are particular to each of you, and then we'll have to answer some of these later online. Christina just mentions, Derek, this is for you. What is the status of the Enbridge working with municipalities and builders with the ground source heat pump connected to communities? I think you answered that.
Yeah, and I mean, I can reiterate. I mean, obviously, within the company, we have more than one division actually that does does relationships with municipalities. So that's ongoing. And then, yeah, like I said, we're in our pre-launch phase right now, but we're actively engaging builders now to see what ground source solutions we can do.
Nice. And a quick add on to that, Kathy asked Derek, the geothermal, you mentioned that there's domestic hot water being done as well. Is that through superheaters? Is that 100% off geo? Is there a gas top up or backup?
Well, so yeah, we'll look at any solution. So the solution that fits is going to be the one that is the priority to either the builder or the homeowner. Okay. I'll just say two things there. In terms of like using a de-superheater, that's, I think certainly the lowest carbon way of doing it, and it carries with it good cost reductions too. Some of the concerns there are around space. I mean, obviously homes are getting, units themselves are getting smaller, and you do need to find the space for all this equipment. So it can be a balance sometimes, picking exactly what you want in there for the project that you have. Yeah.
Good. Quick question for you, Peter, and then I'm going to come to Sean with the building science question. Just knowing that we've got about 5 minutes here. You folks did really well, by the way. You were all like bang on with your timing, so this is perfect. A quick question, and this is very specific to the wood. How would a private woodlot owner get involved with, say, FSC certification and producing these wood products?
The biggest question with any certification, at least in Canada, is that they're geared to larger holdings. I'm a director of a community forest in Sea Shoulder. For 15 years, I was a director, and just this past April, I let someone else take that. I decided not to run again. And we have 10,000 hectares. That's not big enough to get any of the certification systems. I know that SFI and FSC are all looking at smaller tenure methods, but it's difficult. And as for if you're a private landowner, you're allowed to actually have a sawmill on your property, or if you're not allowed to have a sawmill on your property. That's just a Ministry of Forest rule. Okay. And it has to do with paying for the logs. If you're processing right there. But a lot of the products that we make are big investments. Cross-laminated timber, $50-60 million for an efficient plant. A wood fiber insulation, $100 million. That investment will come as people pay attention to more than just the profit.
Nice. Good. So building science question, Sean. Let me know if you're comfortable answering this. So Ali noticed your overhangs, right? Those little projections for solar shading. Beautiful. I mean, I love that. That's a detail. I think many people should look at that. But he asked you a question about solar heat gain. He said, wouldn't it make sense to pick a window that has a really high solar heat gain to let in the free heat and then just use overhangs? What would your answer to that be?
I've done that on my own house. Great for a custom. The townhouses you looked at, I pushed them 1.5 meters away from the property line. So I had to have on my sites, I'm known for packing a lot of density, and we don't leave a square inch unturned. So to get the size of the units that I wanted, I would prefer to push the front of the building as close to the property line as I could. What he's talking about would be an idea. I don't trust, I wouldn't want to bake my residence.
That's right. Yeah.
I don't want to build an oven. So possible. Yeah, possible. Yeah. But I will say that customers don't understand any of this. And using a car analogy, and maybe even for a builder too, who cares why the engine is more efficient. You don't need to know if it's a double overhead cam or if it's a V12 or a V6 or whatever it is. The customer wants to know that they can get in the car, turn it on, and go to the gas pump as infrequently as possible. So if you're going to rely on a customer to have a high solar heat gain window, have the overshade, then pull down their drape at the right time, open the window at the right time, get the cooling from the ground floor up to the top floor, it ain't gonna happen.
No,
it's not gonna happen.
And I think one thing just to share back with Ali is Ali, out of all the net zero homes and even passive house projects we've been involved in, I think we're past the point of specifying high solar gain windows.
Yes.
In most cases, they cause more issues than they actually help. We have houses, passive house, net zero homes, that the solar gain is so high, 0.6, 0.7, that the house actually needs cooling in February. Yeah. So again, we got to be a little bit careful with that. One question that was just a statement just shared, Richard Martins just commented on the concrete, which is sort of interesting, more of a statement than anything. Just be careful of admixtures. Obviously, the curing time for the concrete changes. So for instance, a lot of these things like blast furnace slag, fly ash, when they add, what happens is you do have to change that in the winter because you do need to do like a seasonally adjusted rate. So absolutely, the devil's in the detail there. Sean, one of the other questions for you, then I think we're going to start to have to wrap up. It was actually over in the chat. You just asked the question about, you said centrally throw-in system. So I'm going to just reword this a little bit. You're talking about your air distribution system is not done by displacement out of the floor. You're actually using diffusion that comes up high. It's centrally ducted and it mixes the air in the room. Is that right? Is that sort of the...
Correct. And that's possible because of the guarantee of the air tightness. It's possible because of the thermal envelope that we put out there and the windows. What I neglected to mention earlier is that site actually is all done by air source heat pumps. So pretty different. But the guys who designed that are brilliant. They know what they're doing. And I pushed back and it's working. But it's something you also have to get past the city. They have to actually allow it, because most building inspectors will walk out on site and say, why isn't your diffuser underneath the window? And when you talk through all of those items, that's the only way you can actually do it. It's a whole package. Right. You can't just say, I'm going to do the center high wall and have it work unless you do everything else.
A little good news for Sean on that point. There is a brand new design manual. There's been an update to the HRAI residential air systems design manual that now accommodates for multiple velocity systems and moving the diffusers, because we know that, so many building officials and codes reference that design manual. Now we can actually design like that. So I'm sure it's people like you doing this, sort of pushing it to get stuff like that.
Not me. It's the guys at HVAC Designs, not me.
There you go. Nice. You know what, fellas? I think we're going to wrap it up. Thank you so much for today. I do just real quick. We've got a Builder's Digest that is available there. It's a little news article that comes out. It's for home builders. It's all about building science, lots of articles. The second part of the series, they're going to try to add on to what we've heard from Derek and Peter and Sean today. We're going to have Chris Magwood and Stephanie Coleman come on the 24th and do part 2. And we've actually asked them to say, Stephanie, give us your opinion. What are you seeing when it comes to carbon and ESG in the residential sector in US and Canada? And then the thing we've asked Chris is, Chris, what are the things we still have to figure out yet? What are the things we really aren't sure yet on some of this stuff? Where does the research need to go? So we're gonna dive deep down the hole. Gentlemen, you've set us up very well today. Thank you for your help. And folks, thank you for attending. And if there's any additional questions we haven't answered, we'll try to get those out. You'll be getting a survey from us today. Please fill it out and give us your opinion. But again, going back to our experts today, you guys did an absolute smash up job. So thank you for your time.
Thank you, Andy. Thank you, everyone.
Thanks. Take care.
Have a good afternoon, folks.